to meetup number 159 of the Melbourne AWS user group. The meeting where anything that can go wrong has gone wrong, but hopefully we will have some great speakers for you tonight. We'll start off with an acknowledgement of country. The Melbourne AWS user group acknowledges the traditional custodians of the land on which we meet, the Wurundjeri, Woi-wurrung and Bunurong peoples of the Kulin Nation. We pay our respects to their elders, past, present and emerging, and recognise their ongoing connection to this land. We extend that respect to Aboriginal and Torres Strait Islanders peoples here today or watching on our stream. We operate through a code of conduct. The short version is up on the screen there. The long version is on our website. The short version is be nice to each other. This is a pretty friendly place. We'd like to keep it friendly. If you have any issues at all, come and speak to myself or Rob, or if you go to the code of conduct, there is also a place you can anonymously report if you wish to do so. We're also on the web in various ways. We have our website there, melb.awsug.org.au. We're on LinkedIn with the AWS User Group Melbourne, and we are on YouTube at AWS Melb. So for anyone that's watching online, you already know that. But if you're in the audience and would like to watch, can't make it in, you can watch live on YouTube. We also accept comments from YouTube. So the order of ceremonies for tonight, the introductions, which I'm doing right now. The What's New section, which landed in my lap a couple of hours ago, and I have not prepared it all, but I will do my best. Then we're going to have a talk tonight from Nolan, from zero to first deploy. So Nolan will be a brand new speaker, so I expect everyone to treat him well and give him a warm welcome. Following Nolan, we go completely the opposite way to Matt Gillard. Matt's done plenty of talks. He's a seasoned speaker, and a shorter version of this was presented at AWS Summit a couple of weeks ago. And then finally, we wrap up with Marketplace. We do this as a who's hiring rather than a who's looking for jobs, because if your boss happens to be watching on the stream, there might be some interesting discussions tomorrow. And then we wrap up about. So, as I said, there's ways that you can ask questions if you're online. If you're watching in YouTube, you can ask questions directly in the chat or at the #Melbourne channel on our Slack. Can't do this without our sponsors. They help provide the food, which unfortunately make it tonight, but usually it's really good, so definitely come back. So Mantel Group are our gold sponsor, and Civo are our silver sponsor. And for everyone that's here at NAB Events Hub, NAB is our venue sponsor. So thank you very much to all of those. Without our sponsors, it's really difficult to put on. And as I mentioned, you can chat in our Slack channel, and this is how you find us. So we have various channels there with various levels of activity. The announcements, partly cut off by my head, tells you what's new and what's coming out from AWS. AWS outages, which thankfully is not that active. if anything goes wrong with AWS, that's where we do that. And there's a volunteers channel and a jobs channel. Post there if you're looking and you're not scared about your boss finding out. Or if you're hiring, you can also feel free to there. And our general channel, plus many others. So if you would like to get involved, speakers, people that we are constantly looking for. Without speakers, I'll just finish this wrap up and then we'll all go home. But we don't want that. We actually want them. So, and as Nolan will prove tonight, this is a really great place to come and talk if you've not done so before. We are also looking for sponsors. You can reach out to us if your company would like to sponsor, and volunteer organisers can come and approach us if you'd like to help out. Easiest way to get started, either approach one of the organisers at a meeting, or you can jump on the volunteers channel in our Slack. All right, we're not the only game in town. This is the next big thing that's coming up, AWS Community Day. This is being held in Brisbane in October. I think it's $20. So really cheap. You obviously need to get to Brizzy, but it's on a Friday and it's a great long weekend if you want to go. I did that last year, and this year I'm on the committee. Just because you attend doesn't mean you'll automatically be put on the committee. I did it because it was such a great event. And that's put on by the community as well. So it's like extended user group, lots of talks throughout the day. And it's, yeah, last year was a great event. Should be really good this year. Bit closer to home, you have the AWS Programming and Tools Meetup. So that's going to be on Wednesday, the 10th of June. So this one, bring your laptops, and this is a hands-on workshop. Have Women in Cloud meeting up at the REA building. That's on the 4th of June. And the AWS Well Architected is at the AWS offices, Collins Street, and that's on the 17th of June. All right, now we move on to what's new. This is where we go over some of the new features for the last month, and this is about the first time I'm seeing them as well, so let's see how I go. So in Melbourne now we have Amazon Aurora DSQL is in the Melbourne region. We're getting the new C8GN instance types. And for those of you that do a lot with video processing, Elemental Media Tailor now provides automatic secure integration with Google's ad platforms. So usually though, that's for people who are doing streaming and those sorts of services. In Sydney, we also have the new C8GN instances. Elemental Media Tailor is also there. This one, Sydney also has some expansion of some SageMaker Studio notebooks on some bigger instances. And we've got the region expansion of G6 instances on SageMaker notebook as well. The database front, there's a new DB type, Extend DB. So this is open source DynamoDB compatible. So if you want to try that out, that's relatively new. I don't think that's come out to Sydney yet, but you can go and check that. And RDS Custom now supporting the latest GDR updates for Microsoft SQL Server. You're running SQL Server on Amazon RDS. in compute land, if you're doing stuff with Mac instances, and that's relatively niche, but they've now got the M3 Ultra available. Don't think it's changed, but yeah, the Macs, although there's a per hour billing, there is a minimum of 24 hours you need to have. So yeah, that's something to look out for. But yeah, if you're doing a lot of Mac stuff, it's an option now in AWS, the M3 Ultra size. Plus a couple of new large instance types. Your R8, M8, IDN, and IDB instance. Machine learning, AWS MCP server is now generally available, and that has replaced a whole bunch of other specific AWS MCP services. So I used to go to the AWS Labs Git repo. They had some really cool MCP servers. This one now sort of takes place a bunch of those as part of the Amazon Toolkit, Agent Toolkit rather. So this now uses the MCP server. So yeah, it reduces a lot of the MCP tools that you previously need to have. So got skills and things in there. So if you're doing a lot with AWS agents, look at those two, the MCP server and Agent Toolkit, plus a whole bunch of other things with, well, that was sort of a big one. Cloud Platform on AWS is now GA. Basically, it's just billing through AWS. A lot of the stuff still runs on Claude. So you know, have a look at that if you still do Claude and have one bill. And yeah, quite a lot of new Bedrock related things, new things every day. So if you're in the AI space, just keep an eye on the updates. Also, networking. So CloudFront announcing pass-through mode for mutual TLS viewer. This is a big one. AWS Interconnect. This is AWS realizing that there are other clouds out there, and you may be running stuff on other clouds. So this gives you a way for your AWS accounts to connect directly to other cloud providers. So Azure, GCP. GCP is the one that has been existing. Oracle Cloud Infrastructure is in preview, and Azure is coming. So yeah, surprising AWS announcing that there are other clouds around. So yeah, security. So security agent now supports full repository code reviews. Security agents, one of your new frontier services that was announced at reInvent. So previously it was mainly for doing pen testing. There's now expanding a little bit more, and I would say that plus the DevOps agent, just keep an eye on them. They're new, they're growing, new features all the coming out. Organizations now support higher quotas for your service control policies. Good, you can have a few more of those, so you don't need to try and wrap things up into only a few. Prefetching of IAM and IAM role assumption for Secrets Manager agent is now available. More updates for Security Hub, and yeah, Secrets Manager adding managed external secrets support for Datadog, vended keys, and Snowflake programmatic access. So if you're doing things with Snowflake, Datadog, more interaction with Secret Manager there. Yeah, and again, the security agent adding verification scripts for your pen test findings. So previously, just did pen test, and that's just adding on to what it can do. Yeah, security agent, DevOps agent, interesting times as they're going through and getting more and more features added to it. DevOps transform agents now available in a whole bunch of your agentic coding platforms. CloudWatch logs have query result limits. That's nice. SAM-CLI, adding your CloudFormation language extensions support. So that's helping if you're using SAM for your serverless. And a few things around billing conductor, help with account visibility, and billing transfer inventory. And CloudWatch Logs Insights has some new query commands and functions to help you query your CloudWatch logs. Right. And the final stuff is AWS capabilities by region. Now supports availability notifications. So that's a place you can go and see what is available in your region, so you can get alerted to new things, new features that come out. And reference stack outputs cross account and regions with CloudFormation and CDK. So you can reference those outputs across accounts and regions. And AWS Deadline Cloud, I'm not sure how many of people will actually use this one, but now supports browsing job attachments in the monitor. So Deadline Cloud is sort of your render farm in AWS. Anyone here is doing lots of rendering. And that's the wrap up for what's new for this month. So yeah, we'll now welcome Nolan.
Thank you, Madam Business. Yeah. Hi, everyone. My name is Nolan, and it's my first time to be a presenter. Yeah, and today I want to share my beginner journey learning AWS. So basically, how I went from having basically zero cloud experience to deploying my first real project on AWS. And yeah, this is not an expert talk. It's more like a story about mistakes, confusions, and lessons, and eventually discovering a much simpler way to approach cloud architecture as a beginner. I know many people here are far more experienced than me, so I'm here to just share a beginner perspective. Yeah, so just a little bit about myself. I'm currently doing Master of IT at University of Melbourne. I also work as a part-time research assistant and a full-stack developer. Yeah, so mostly I just focus on building web applications and backend systems. And recently I became AWS Cloud practitioner. And over the last few months, I've been getting interested in cloud technology and scalable systems. The reason I started learning AWS was pretty simple. I wanted to move beyond localhost and actually deploy something real for real users. As a full stack developer, I always heard about scalable systems, cloud native architecture, and distributed systems. And I wanted to understand how those things actually work in practice. So at the time, I honestly thought cloud deployment would just be like upload my code, click deploy, and done. But yeah, that's not actually things work. Yeah, and was my first AWS deployment architecture. I containerized my backend using Docker, and I pushed the image to ECR and deployed it through ECS Rugged, and connected it with an ALB application load balancer, and configured public and private subnets across multiple levels. And the important thing is, at that time, I barely understood what most of the servers actually did. I was mostly following what ChatGPT said. So I actually jumped straight into a very complex infrastructure design as my first AWS project. Yeah, and this was the moment AWS kind of exploded in complexity for me. Suddenly, I have to learn like a lot of concepts like the VPCs, IAM permissions, net gateways, route tables, security groups, available zones. And the hardest part was that everything depends on everything else. So even one wrong security group rules and one wrong subnet configuration issues can result in nothing works. At that time, I actually spent way more time debugging the infrastructure rather than actually building my application. Yeah, so in the end, I realized I had massively over-engineered the whole thing. That was a pretty small student project, and I accidentally built infrastructure that looked more suitable for a production startup system. And then it came the AWS build as well. So like cost me like $70 just for a student project. So yeah, about $70. And honestly, like $70 isn't huge in industry, but for student project where almost nobody is using that, so it's kind of hurt. And looking back, the main risk was I just copy a production style architecture before understanding anything fundamentals. Yeah, so after the experience, I decided to step back and actually learn cloud computing properly instead of just deploying things blindly. I started studying AWS concepts systematically and learned architecture fundamentals, and eventually complete the AWS Cloud Practitioner certification. So like the mindset for me is I decided to learn the infrastructure before learning the concept. And I think this is why so many beginners feel overwhelmed by AWS. AWS immediately exposes you to enterprise scale infrastructure. As a beginners, we often make a few common mistakes, like copying production architecture and using too many services. And honestly, do beginners really need all of this complexity just to deploy a simple project? So at the point, I realized maybe there a better way as an entry point. So yeah, that's why I started learning the serverless architecture. Yeah, and first, serverless does not mean there's no server. It just means that you don't need to manage the server by yourself. AWS handles most of the infrastructure management for you. So instead of provisioning EC2 instances, configuring load balancers, and maintaining network, you can focus more on your application logic. And for beginners, I think that's a huge. Serverless usually means simple deployment, automatic scaling, lower operation overhead, and often much lower cost. Yeah, so I Yeah, so I suggest this architecture to beginners as an entry point to AWS. So the API gateway basically act as the entry point to HTTP requests, and Lambdas can run your backend logic only when needed. And then you can connect servers like S3 or S3 bucket or DynamoDB very easily. So compared to my original ECS setup, this architecture is dramatically simpler. And the biggest benefit for me was I could finally focus on building application features instead of constantly managing the infrastructure. For beginners specifically, I honestly think Lambda plus API Gateway is one of the most best way to start learning cloud architecture. Yeah, and here's like a very small demo, a recorded video of like just show how simple is it like to build a backend using API Gateway and the Lambda. So for now, I'm creating a script in Lambda, a Python script, just for a very simple backend logic. Yeah, just a very simple health check, just for demo. And create API in the API gateway. So yeah, and just the host setup, the configuration is pretty simple. I connect with Lambda and add the HTTP request you want to yeah, and that's basically done. And in the API gateway, you can just get the URL for your backend. You can just type using the API just created. Yeah, I think that's all I want to share today. Yeah, just a journey about my AWS and a small suggestion for beginners as well. And in the past few weeks, I also been working on investigation on the how to integrate S3 bucket with Rack. So yeah, hopefully I can see you guys in the next
All right. Thanks so much, Nolan. Does anyone have any questions for Nolan?
Yeah, nicely done for your first presentation. My question would be, can you give us an insight into what the project was that you were trying to deploy that you thought might have needed such complex infrastructure until you realized it didn't?
Yeah, it's the mobile app. It's about like can keep tracking you sentimental, like your mental health.
Okay.
Yeah, so it's very small app. I use AWS just for pure interest. I want to like because AWS is very popular in the industry, but in the uni, like barely, like about no student is talking about it. So I want to like give it a try.
Yeah, nice.
Cool.
How much performance difference you have seen in both the setup?
Pardon?
The performance difference, the difference in performance.
Yeah. Oh, you mean the Lambda compared with ECS?
Yes.
Well, it's actually I think it actually depends on the scale of your back. Like normally, if you're dealing with very complex backend logic or like if you have some global, I think ECS might be a better option for you. But in terms of performance, I think because the ECS, well, it actually depends on the backend you're working on. Yeah.
Cool. One other over here.
You've got your learning experience from this. It's just simple yes or no question. Do you think that using AI services will allow you to build some product without learning? So is it even possible for a beginner to build something without learning and studying fundamentals? Because that's the purpose of AI coding. So you don't know the technology, but you're using it. Is it ever possible?
Yeah, my answer is yes. And back to the example I have been working on, the ECS, is I just follow ChatGPT guardians. But I think the problems of using AI is you don't know if the architecture ChatGPT suggests for you is suitable for your project. Because like ChatGPT at the time had limited knowledge and context for my project. Yeah, so you can see in the example, it cost me $70, but we need to get like 10 users. Yeah. So my answer is yes to AI. If you for beginner, just using AI is possible, but the result may not be ideal.
All right, thank you so much. All right, everyone. We now have Matt. Matt works for V2 AI. He's spoken here before in many places, including at AWS Summit, and he's going to give us an expanded version of his Summit talk. So thanks, Matt.
Thank you. Everyone hear me? Yep. I sometimes walk around, so I might go off screen, but you'll hear me if you're online. Hope. Thank you. Okay. Thank you, everyone, for coming out on this very night. Rain, but it's not raining now. Just a little anecdote. I gave this talk in Sydney 2 weeks ago. The day before, I was doing my check, and they said, "Oh, we can't read your PowerPoint." Oh, and then I had it open in my PowerPoint, and I closed my PowerPoint, double-clicked on it, and I couldn't open it either. So 24 hours before my talk, my PowerPoint opened. I do have an older version, but anyway. Turns out Claude can help with this. So Claude Desktop pointed at my PowerPoint presentation, and it found out that there was a font ID that was blanked out for whatever reason. It fixed that, the whole presentation came back. So please use your Claude for good purposes. That is one good purpose that Claude is useful for. There are many others, but just there is lots of good uses. Some to how many times have we had a corrupt document that we haven't been able to recover, we've had to rewrite it or whatever. Repair button never worked. So anyway, thought you'd like that. So I'm not here to talk about that today. I'm here to talk about OTel, which is short for Open Telemetry. I have a startup called Good8 Connect, which is about falls detection in aged care. So we put these devices in rooms. They can go on the wall, but most roofs, bedroom and ensuite, and it sends a little millimeter wave radar in the room to detect where someone is, if they're in bed, if they're walking around, or if they've fallen, it'll send an alert. It's always sending presence alerts, but it can also send event alerts to people who are carers to come and check on the person. So I gave a talk last year at Summit, which was sort of the genesis of that application, and since then we've been paying customers. So I'm actually building. So part of the problem is that we have a lot of data. So we have a lot of JSON payloads that come out of this. It's probably, I don't know, a few 30 bytes or something. It's not huge. but there's lots of them in it. And sometimes when you're debugging a problem, you need to know where that came from, going to. And observability is sort of one of those key items. People sometimes forget about observability. We'll do some monitoring, we'll do some logging. But having at least the basics in place is useful for debugging later on. You might not need it now, but you will need it. So, I'll skip the agenda. I'm just going to go through 3 patterns. I'll give you a bit of an introduction on what it is and the patterns that I've found useful in my sort of asynchronous pipeline. I'm abusing it a little bit with asynchronous tracing, but it's useful. So onboarding this customer I mentioned earlier, we had a small problem with the onboarding process. You have to put in your phone number as an escalation point, and the phone number verification failed. Turns out it looked like it was okay on my end. It looked like it was working, and yet he was getting an error. I went back to my computer afterwards, and I used Honeycomb. And Honeycomb has an MCP plugin for Claude or Beck, whatever it's got. You don't really need to read all this. It's just like for effect. But it's actually the real query that I did to figure out what happened during that process. So it gathers all the logs, all the errors, maps them together, and then at the very end of this, it'll give you a timeline of what happened during that process of validation of the phone number. And you'll find out that, so what I was actually doing, sending a link in the text message, which is clicked, which turns out that worked fine, but it also has a code. So if you enter the code after clicking the link, it's reused. You can't do it again. So that's why he was seeing the error. So basically, that's the timeline there. That was sped up. So it might have taken like 3 or 4 minutes. But imagine if you're doing this by hand, doing the tracing of the logs, all asynchronous, Lambda-driven. Mapping all those things together is a little bit difficult, I guess. But this gives you the time in UTC, all the events that happened, and it tells me what happened, how to fix it. That's kind of why we're doing it. So OpenTelemetry is made up of sort of 3 different things, but I'm going to add a 4th. Just to confuse. So you have logs. Everyone knows about logs. Ideally structured logs. Structured logs are not text, they're text, but usually JSON format, which means that's easy to query. Key value, key value, key value. That way you can get a consistent view of the logs. You can easily query them. There's metrics. So metrics could be CPU memory usage, or it could also be business metrics like users logged in, or there's been 3 failures on this, or whatever the business metric is. They're kind of not as important, and they can be added as you go. Logs are probably the most important out of all these. And traces. Traces are basically recording the length of time that a service is run, and the start and end time, the duration, with some attributes around it. So it could be a user has clicked on a link on the front end, gone to the API, done a thing on Dynamo, come back with a result. That whole thing, trace, tells you when the API was hit, what time, when DynamoDB was hit with a get query, book item, whatever it is, and it'll tell you, the whole, how long that, which is actually very interesting because when you're doing it from a web browser, you can't gather all this information from a web browser. So you gather operating system, fingerprint of whatever device the user's using. So you can figure out all your Mac users, your Windows users. Problem just with Windows people, or Mac people, or whatever, or a mobile device. All these different attributes you get as part of these things are very useful. Maybe not initially, but later The last one is correlation IDs. So having a correlation ID for all the logs that you put into your system is super useful. That could be as simple as the incoming trace ID, or it could be a function request ID. Whatever the incoming ID is the system gives you, I call all that the correlation ID, which I added to the model. Because you can search for that and figure out how the process runs and all what services. So traditionally, everyone does monitoring. So, you know, something fails, you know why it fails, so you monitor that thing so you know if it fails again. But what about the things you don't know about? Like, you can't do monitoring for those because you don't know what they are, so you don't know how to monitor. So that's what observability does. It gives you the tools to be able to query these unknown unknowns. One of the things that really helps. You can still have monitoring because you still have things that you need to monitor, like things that you know might fail at a certain time, but you need to have both. So serverless can be hard to debug because you've got all these bits and pieces, right? So for a synchronous request, as I said, you've got the browser, the API gateway, you've got, you know, 1,000 Lambda functions with all different logs, and you've got to sort of trace those things together. And, you know, they might be talking to Dynamo, they could be talking to Postgres, or whatever. And then when you've got an asynchronous pipeline, it becomes even more complicated because then you've got queues. You've put a message on a queue, which is processed by a Lambda function, you know, which does this. So it's I'm not saying serverless is complex, yes, but also the server way is complex because you've still got all these, the processes are still running somewhere, and you've still got all the logs, you've still got to correlate, you've got to search. So I guess that's why sometimes people think serverless is harder to debug because your logs are sort of scattered all over the place, but put your traces in correctly, then it's not as OpenTelemetry is difficult, I'll tell you that for free, because in Python it's actually pretty easy. But once you start doing Node, my stuff's all Node, but that's very hard. There's a lot of different libraries, and it's kind of hard to piece it together. And things need to be put together in a certain way for them to work. So Honeycomb or any of the other OpenTelemetry providers provide extensions. The Honeycomb extension is okay. I didn't use it. The AWS distribution for OpenTelemetry, ADOT. Lambda layer is AWS native, opinionated for X-ray, and AWS services, which is fine if you're using all that stuff. I'm not a huge fan of X-ray. It's a little bit complex. Once you start using other providers, you'll see how it's improving. It's improving over the past few years, but I personally like Honeycomb. Rotel is a Rust. Everyone's writing things in Rust. A lightweight collector written in Rust, which can, log to any provider. That's fine too. Okay, a bit of a test. I'm not using that. But what I did was I vibe coded, vibe engineered. Just the basic OpenTelemetry foundation, which is used in all my sort of middleware functions. And once it was set up once, I just import it everywhere, and I don't have to touch it. It's not hugely complicated, but it gives me some control over the standards about what I'm logging and where, and it's all fast layers, Lambda layers. Sometimes add a bit of startup time to functions, like in the order of milliseconds sometimes or more. I was finding up to 500 milliseconds. So having the in-process version worked well for me. Before Claude or Codex, I would not touch that because there's too many different ways to go wrong, and it's hard to configure it if you're sort of coding it from scratch, because there's different libraries, different versions, APIs in the right The other important consideration and thing you need to know about OpenTelemetry is that there's sort of semantic conventions for attributes. I've just put some examples here. You can, store that this message went through SQS, an SQSQ name, DynamoDB table names, cloud provider, basically key value. Think of them all as key values, which are logged either in the span or in your log file. Either way, doesn't matter. But that way, when you've got your trace, or your waterfall trace, which I'll show you an example of later in the presentation, then you can see at various points of that trace, I did a DynamoDB call, what was the table name? So you can click on that and see the table name. So that sort of stuff is pretty useful. There's a URL at the bottom which gives you the standards around semantic conventions, all different cloud providers, well documented. One of the things that I found out that caused me quite a lot of pain for quite a few months, you're supposed to be able to get instrumentation on AWS SDK calls out of the box without any configuration. Turns out that you've got to, in TypeScript, you've got to make sure your OpenTelemetry import, which is all the OpenTelemetry SDK, which actually plugs into that AWS SDK, is the very first thing. I'd put it here. Too late. You've initialized your AWS client. It's not going to be able to hook into it. So it's actually got to be the very first thing. And Codex told me that. Or, oh, everything looks fine. Do this, do that. I'm like, no, it's not fine. But eventually, different AI did a review and found my problem. Don't be me. Always mate. I use SST as my infrastructure as code, serverless stack. Good, go use it. Pick it up. Great. I've got an example for Sam as well. So this is the setup that I've got for Honeycomb. It's just basically an API key, an API endpoint, which is hooked into all the Lambda functions, so they've got somewhere to send all the traces. So that's one-time setup, and then any function that I create automatically inherits these environment variables. And I also have to have, so by default, your Lambda functions gets built by ESBuild, which changes the format. It's got to be common JS, which is the older style function. Otherwise, none of the open stuff works properly. So there's just a few little bits and pieces that are kind of not well documented, but especially when you're doing Lambda, it's very important. SAM has a similar setup. So if you're using SAM on AWS, which is a common way to do serverless on AWS. So 3 patterns. Pattern 1. You can actually, so I wanted to set up automatic log exports, so I didn't have to think about it. If I deploy a new function, I want the logs to go to Honeycomb by default without me thinking about it. You can actually, within the Lambda process, automatically send it to your provider of choice. It does go to CloudWatch logs as well, but I want it to my OpenTelemetry provider as well. But if you do it in the Lambda process, it the Lambda sort of hangs around a little bit longer while it's uploading the log. It's a little bit fraught with danger, with some errors every now and then. So I prefer my Lambdas to finish quickly, let the asynchronous log deal with being going to CloudWatch logs, and then at the back end, it'll get sent wherever I want it. So when you create a new Lambda function, there's an API call, create log group, which goes to CloudTrail, which you can hook into EventBridge and put a Lambda listening to that. So whenever there's a new log group, set up a subscription Lambda. If there's a tag on that log group to be excluded, sometimes there are logs that I don't want sent for various reasons, then if the tag says, yes, I want to keep this, it'll put a subscription filter on that log group, and a subscription filter basically tells it to send it to Firehose. And then Firehose has an endpoint, which is in my case Honeycomb, the HTTP endpoint. So that's a one-time process for all my Lambda functions. So whenever there's any logs created, Lambda functions, and I've got API gateway logs as well, they'll all go to my logs provider or whatever, and safely there. So pattern 1 done. The tip. So the second one is to use MIDI. So MIDI is if you've got a lot of Lambda functions, there's a lot of setup and checks that you want to do. You might have some authorization checks, open telemetry that I want to get set up. So MIDI does all that sort of hard yards. It's basically a wrapper for all that stuff. And I have kind of 2 wrappers. One for API gateway, so synchronous requests that come from the front end, or other API clients. And the other one is a generic Lambda handler, which is used for async, like listening to SQS queues, those sorts of asynchronous. So they've got slightly different needs, each one. The API gateway one especially has all those authentication concerns. So my pattern is that the business handler is basically where my business logic is, and that gets wired into my MIDI handler, the base handler in that example. I've got some configuration variables that I put in there. I've got a consistent logger that I use, which is Power Tools. You might have heard of Power Tools. Power Tools logger. Power Tools has lots of good structured logging utilities. So I add that in there. So that way it's all consistent for every. So this is a bird's eye view. This talk is probably getting to 300 level now because I added more information to it. We can pretend it's 100. I'll talk through the important parts of this. So my API gateway handler takes in that business logic as the first parameter. That's where the big arrow is pointing at. And then it'll execute that, passes that through. And then it takes the open telemetry API and pulls out the parent context. So if it's come from a front end, it'll pull out the context front end. When a user clicks on the front end to pull an API, a trace parent header is added to the HTTP request. That's what this does. And then it's adding to that trace, any Lambda functions I call the HTTP. So there'll be a span for Lambda function call, a span for HTTP request, and that's all that will do. And then I'm adding some information to the logs, their attributes, so they'll come up into my structured logs as trace IDs, user ID, what user was authenticated, and at the bottom there's a bunch of infrastructure type things that I need as well, like other bits. So yeah, everything is standard. You get standard spans, standard log fields, standard context, and standard error behavior, which is super important. Having standard error behavior. So pattern 3. Pattern 3, async needs explicit handoffs. So the problem with standard open telemetry is that once your request disappears into an asynchronous process, like a queue or something, you can't really trace it anymore because it's out of flow. And you lose the trace. So the way I get around that is to have inject the correlation ID. So the request ID or the trace parent into the data that's being transmitted. So in this particular example, the incoming request is like that JSON payload from the device, as I said. I have a meta header with some internal headers data that I use. So I inject the correlate request ID that came in and any trace parents into that data field. I'll show you an example in a second. And then I can pull that out later and then continue the trace. So I'll show you an example. This is a real example of a payload of a full event. I have a meta key at the top, which is like internal things that I care about. And then the payload is what the device is sending. So in this example, I've just highlighted the two things I've added. So I've added a correlation ID, could be the Lambda function request ID usually, and then a trace parent, well, if there is one. And if there's not, it'll create one. So the OTel will always create a trace parent, even if it's not created. Normally they're created on the front end by the browser using the Honeycomb, whatever retail provider you're using API. In this case, and if it's not there, if it's not a front end request, it might just be a webhook from a third party integration, then it'll. So I'll inject. So then when I'm using that, I inject that into the header by using the Shell API, which is all provided. The producer enriches the span. So in this example, the propagation inject pulls it out of the OpenTelemetry context, some OpenTelemetry APIs that pull it out, and I get that trace parent ID, and that's how I get it in the meta payload. So that's how the code effectively does that other thing. And then we've got a consumer. The consumer takes the meta trace parent, which I showed you in that JSON payload, puts it into the telemetry context, and then if there's a correlation ID, it'll attach that as well. And then that way, anything that happens, in this example, what could be running this code, it might be a Lambda function that listens to an SQS queue. It pulls that data payload, pulls that information, so I can keep tracing that. I'll show an example why that. So this is an example of the Honeycomb waterfall. OTel waterfall is not just Honeycomb, Datadog, they all do it. All the providers do it. In this example, there's a post request to a webhook, which does an S3 put object. So you can have custom spans well for your business logic if you've got long running functions. In this case, these are all default pretty much. Put object is provided by S3. That's a Lambda function. Another S3. There's an IoT data plane, and then that's pretty much it. So you can see the whole flow. That's a whole asynchronous flow which comes off an SQS queue, and that's why there's a delay of about a second from when it hits the webhook to when it gets into a queue, when it gets pulled off the queue about a second later. Normally you wouldn't be able to do that trace from start to finish when it's gone through some sort of asynchronous endpoint. And with this information, you get lots of stats about average time of the transaction being processed. Was this event delivered? These are the processes. And then similarly, I still use CloudWatch logs. You can use log insights. And if you've got a correlation ID, you can give it all your Lambda groups. I've got a /cc prefix where all my Lambda functions, where there's a whole bunch of stuff there. And there's also AWS Lambda in the IoT log group as well. And you can just search that a particular ID, and then it'll give you all the logs for that particular correlation ID through all the functions through, and which you can see sort of on the right-hand side. You can see the log messages that flow, and you can see this particular flow went through 9 different things. It took about 2 seconds. So my 4 takeaways of this talk are: make sure that all your logs go somewhere. Watch logs is fine. Go to another third party. The default AWS SDK spans, which I showed you in that waterfall, get you a long way. You don't have to have custom ones. You don't have to do any extra configuration. Once they tell you you get all that for free. That's configured properly. Carrying context across async handoffs. If you've got data payloads or things, you can always add that to your meta field in the payload. So you store that with your data. It's only a small amount of extra data, but the power it gives you later if you need to trace it is super handy. And the 4th one is to delegate all your infrastructure type things like OpenTelemetry, authorization code, all the things that you have to do multiple times to some sort of middleware, like if you're building a business system, you'll save a lot of time later. So that's me. I'm a community builder, a podcast, a dialogues, look up. I've got serverless meetup. We run every few months when we get speakers, so if anyone does serverless, quick plug. And I'm also principal at AI as well as my startup doing aged care. And if I quickly show you, I just did a trace were away in front of the audience, but I just picked a recent trace ID, and I'm working on a addition to the product. And in this particular example, it's gone to Honeycomb and pulled out the trace ID. It's gone through. It's told me where it's gone, and then it's also about 100 milliseconds later gone to a queue. So there's an asynchronous queue hop. And allowed that extra information gathered because it steps that trace throughout the process, and I can see where that data is actually ended up.
All right, thank you very much, Matt. Does anyone have any questions?
Yeah, no brainer. This observability is extremely important for large systems. So I've seen an example of TechOps team getting the similar results, like which service is calling which next one in the queue, and pretty much the same information. Maybe not that visual, and it was achieved by utilizing just Amazon Kiro. So it's just Kiro AI and whatever behind that service. It's just explore the signals in various logs. It could be tens, thousands of them, and building the output. So the question is, do you think it's feasible to get this observability result without building observability system on top? Just using we have logs, we have Kiro.
You can, but the problem is, I guess that's like your crowbar when you have nothing else to do. You always have that. And if you've seen Claude or Kiro or whatever it is, looking for something in logs, it can be quite inefficient until it figures out. I mean, you can create a skill to sort of guide it the right way. These sorts of logs are here. Giving the right context is important. So yes, that has its place, but having a deterministic system where you've stored this stuff somewhere is also useful, especially when there's actually not that much to set it up in the end. Maybe it looks like I've overcomplicated a little bit, but I don't think so. It's relatively straightforward to set up, and once you have that in place, your hero can query this, and it's in a more efficient way. Like that one that I just showed you, that waterfall stored code, like 2 minutes ready, because it's got the MCP honeycomb, which does all the API calls. How it gives you a deterministic way to do it, which saves time. Could you do it the other way? Yes. If it's only occasionally, maybe it's fine. But you don't need all this at the beginning. You find your problem areas, those things. It's more efficient to query later. What do you want to say?
Cool. Any other questions? Yep.
You have used OpenTelemetry SDK in process.
Yes.
When should we use in process and when should we use it as a sidecar?
So I guess if you're in a container system, you probably do a sidecar or something. Lambda in process is probably the most what a layer is really. But I guess it depends what you're doing. And also when there's so many ways of deploying it, because you can have a proxy on the system which gathers everything. So if you've got a big Kubernetes cluster, you might have a proxy, and then you configure that. It really depends on a sidecar is probably useful. Yeah, probably in the container environment, you can replicate it so many times.
All right, cool. Any other questions? Yep. All right. Thank you very much, Matt.
No worries.
Is anybody hiring at the moment? Yes, unfortunately, it seems to be a bit how the market is right now. So, all right, with no one hiring, we will again thank our sponsors, Mantel Group as our premium sponsor, Sivo as our silver sponsor, and NAB for the venue. So thanks a lot to those sponsors, without which we really can't put these things on in a consistent way. And we will meet here again in the last Wednesday of the month, which is the 24th of June. We are still looking for speakers, so if anyone would like to speak, you can either see us or on the website you can put in your submission to speak, or hit us up on the Slack. Any option I will take, and we can do, as we saw with Nolan, lightning talks. So if you haven't spoken before, we are also very happy to help anyone, go through your talks with you, check your ideas, give you feedback, tips, anything that you would like. So yeah, we are here to help grow and improve the community. So with that said, thank you everyone, and we'll wrap up tonight.